In this video, we're going to use the segment and angle addition and subtraction theorems with triangle proofs. So we're going to use those as just kind of a part of a triangle proof. So if we look at what we're given here, we're given that AE is congruent to BD. So we're given that this whole segment AE is congruent to segment BD. And I'm going to just mark that down here too with little brackets. So these whole segments are congruent. I know that AC is congruent to BC and CD is congruent to CE. And if I look at what triangles I'm trying to prove congruent, I'm trying to prove ACD, so ACD, so this triangle, and I'm trying to prove triangle BCE. So I'm trying to prove that those two triangles are congruent, and right now I already have two sets of sides marked. So I'm thinking about my congruence theorems with two S's, so SSS or SAS looks like possibilities. Now, when I look at my picture, I'm also given this entire thing. AE and BD are congruent, which are getting me closer to these sides right here in the triangles, because if I'm given this whole part, this whole side, and if I get rid of this shared piece where the colors turn green by using reflexive property, if I subtract that from both of these large segments, I'll be left with these two parts, which will then be congruent, which happen to be the sides of the two triangles I'm trying to prove. Right now, the pieces that are congruent aren't actual sides of my triangles, so that's why I would have to use the segment subtraction theorem. So it looks as if I'm going to be able to use SSS to be able to prove this. So let's go ahead and start by writing down our given. So I have AE is congruent to BD. And I'm going to be using the segment subtraction theorem with that. So I'm going to leave a little bit of space so that I can do that. And then I'm going to go ahead and write down my other givens here. So I have AC is congruent to BC. And CD is congruent to CE. So these two givens on the right gave me the sides of the triangle. So those gave me two S's. To be able to get that third side, what I need to use is the reflexive property, that shared piece. So DE, remember reflexive property is just kind of like a floater statement, doesn't connect to anything because it's from the diagram. And then using these two, I can subtract off. So I can take AE and subtract off DE. So this whole segment minus this green section will leave me with AD. And DB minus this green section will leave me with this blue part, so EB. So those have to be congruent by the segment subtraction theorem. And then from there, now I have my last pair of sides congruent, so I can check that off. And I can take all three pairs of congruent sides and piece those together to state that the triangles must therefore be congruent. So I'm just copying down my congruence statement, and I'm going to write SSS as my method. And again, we can verify this by checking off, here's the one pair of sides, my other pair of congruent sides, and then the last pair of congruent sides, CD and CE. Therefore, the triangles are congruent by side, side, side. So let's try a couple more of these. So this next one here, same picture, right, as the first one, but very different givens. So this one we're given ACE, so angle ACE, so this entire angle here is congruent to BCD, so this entire angle. So again, right away I'm seeing this shared piece right here. So I see that AC and BC are also congruent, and CD and CE are congruent. And I'm going to highlight the triangles I'm trying to find because there's multiple triangles in this picture. So ACD, I think it's always helpful to highlight those triangles, is congruent to BCE. So that's what I'm trying to prove. So again, I have two sides given to me. So I'm thinking about my methods with two S's. So SSS and SAS. This one, I know nothing about these sides down here. There's nothing given to me, but I do know something about these angles. So if you think about this shared angle, if we were to take away this angle here from both this big angle and this big angle here, if we were to subtract that common angle, you would be left with this piece right here. And if you take this big angle BCD and subtract off this shared piece, we'd be left with this small angle. So what that means is I can use angle subtraction, and then I'll have side, angle, side for my triangles, why they're congruent. So I'm going to go ahead, I'm going to write down my givens. So I have this, these are the big angles. And again, I'm going to leave space because I need to talk about that shared angle, the angle that's congruent to itself. And then I have AC is congruent to BC as a given. And I'm just going to write the other one down here so I have more space. So now when I talk about my angles here, I'm going to go ahead and number them. So I have angle 1, 2, and 3. So I'm going to say that angle 2 is congruent to itself. It's shared among both angles. It's shared among angle ACE and BCD, among those big angles. So I'm going to mention that angle 2 is congruent to itself. Again, that's just a floater statement because it's from the diagram. It's the reflexive property. It's the same angle that's shared. And then I can go ahead and take those and subtract them. So this is the big angle, so ACE. And if I take away angle 2, I'll be left with the angle in the yellow triangle. I'll be left with this angle right here. So I'll be left with angle 1. And then if I take BCD, so if I take this big angle here, BCD, and I subtract off, so if I take this and subtract off the pink angle, I'll be left with this blue angle here. So that'll be the remaining piece. So I'll be left with angle 3. And this is by the angle. So make sure we state what type of figure we were starting with. So we were starting with angles. We subtracted because we went from the big to the small. So subtraction, and then we have to include theorem. So then now when I think about SAS, well, I have my pairs of angles, my congruent angles, and then I already have my two pairs of congruent sides. So I have everything in my proof. We can go ahead and connect those three important pieces of information. So now I can say triangle ACD is congruent to triangle BCE. And this is going to be by side, angle, side. And again, I'm going to just go through and kind of highlight in my proof. So I have one pair of sides right here. The included angle is angle 1 and 3. And then the last pair of sides is right there. So then one more. So instead of having a check your understanding, we're going to do this last one together just because this is all new concepts. And it's a little bit tricky. So let's go ahead and read through it. So we have BCD, so angle BCD. So this entire angle is congruent to FCD. So it's congruent to this entire angle. I purposely made these arcs so that they don't connect because I don't want them to look like one big arc. I want them to look like two separate arcs. So then I have angle 2 is congruent to angle 3. So those small parts are congruent. So right away I'm thinking, well, if the whole things are congruent and then these little parts are congruent, I could subtract those off and get angles 1 and 4 congruent, which is looking like what it's going to be helpful to do. So then I have AC and EC congruent for sides, and BC and FC congruent 4 sides, and we're trying to prove that ABC, so this triangle here, is congruent to EFC. So the problem is with the angles that they gave me, notice that they're not the angles in the triangle. So I really want to focus on getting 1 and 4 congruent by using angle subtraction theorem, because those angles are actually in the triangles versus all of the other angles that were given were not in the triangles. And then it looks like I would be able to use side, angle, side. So that's going to be my goal here. So let's go ahead and write down. So we have BCD is congruent to FCD. I have angle 2 is congruent to angle 3, given. And then we have AC is congruent to EC was given. And then my last given here, BC is congruent to FC. And like we said, these two, if we combine them, so if I take BCD, this whole angle, and I subtract off this little part here, let's actually use a different color. If I subtract off angle 2, I would be left with angle 1. So this is going to leave me with angle 1. And then if we take this angle, FCD, and we subtract off the congruent piece to that, angle 3, I'm going to be left with angle 4. So we'll be left with angle 4. So now I know in my picture I'm going to put 3 arcs on these. And my picture is very colorful and crowded, so maybe not use all those highlighters if it's not needed, but definitely want to highlight the triangles. If it's helpful, highlight away, but sometimes it might make it too colorful and hard to see. But now I can see that this was angle subtraction theorem, because we had the whole things congruent. We subtracted off the parts and got the other parts congruent. And now I can take all 3 pieces. So I have my angles and my 2 pairs of congruent sides. And I can say that the triangles are congruent by side, angle, side. So it's always important to go back and check, did you actually state the 3 pairs of information that you needed to? I have a pair of sides, I have the pair of included angles, and then I have another pair of sides outside of the angle. So therefore I have all 3 pieces of information included in my proof, so I can say that the triangles are congruent. So that's it. So we will look at more problems with this in class tomorrow.